So starting a new chapter, this is chapter 4, counting methods. Throughout the chapter, we're going to talk about the fundamental counting principle, permutations, and combinations. So explore. Let's suppose that you have a red die and a blue die, and we're going to roll them at the same time. What are all the possible different outcomes? So if we'd go through and figure out all the options for B1, B2, B3, all the way up to B6, with all the different R combinations, we'd have 6 times 6 or 36 possible outcomes. So here's another one. Let's say that you are going for ice cream, and the ice cream sundaes come in 5 flavors, and there's 4 possible toppings for each one. So let's say I've got flavor number 1. How many different options for toppings are there? 4. There could be topping 1, topping 2, topping 3, and topping 4. How about for flavor 2? 4 options also. How about flavor 3? And flavor 4? And flavor 5. Okay, so how many altogether outcomes are there? 20, because 5 different F options, and there's 4 different topping options for each, so that would mean 20 possible outcomes. So example 1, how many different 231 phone numbers could exist in the Humboldt area? So how many different numbers are there in the last part of the phone digit? 4. Okay, and how many options are there for each number? 0 to 9, which is how many options? 10 options. How many then options are there for the second number? And the next one? And the last one, 10 also. So how would we figure out how many numbers altogether there could be? Good, we're going to multiply them together because they are not, so that'd be 10,000 in total. All right, next example. Here we have Julius, who's playing on the Crusaders basketball team. The uniform has different options. You could have 3 different options for sweaters, black, gold, or white, and 3 different options for shorts, black, gold, or white. So how many different combinations are there? So there is black, and you could have black, gold, or white shorts with it. Then there is gold, and you could have black, gold, or white shorts with it. Or you could have a white sweater with, again, black, gold, or white shorts with it. So 3 different options here, and 3 different ones for shorts. So 3 times 3 is 9 different options in total. Here we have a luggage lock that opens with the correct 3-digit code. So we know we've got 3 digits. Each wheel rotates through the digits 0 to 9, which means how many possible? There's 10 each, right? So if there's 10 each, that means for part A, there are 1,000 different 3-digit codes available. But then for part B, it says suppose you can only use each digit once. So then how many options are there for your first digit? 10. How about your next one? And your last one? So in this time, there's 720 different possible codes. So now here's an example where it's an or situation. It says either a black face or an ace. So we're talking about cards. So how many, I should say a black face card. How many black face cards are there? 6. Okay, so there are, the number of black face cards is 6, and the number of aces is how many? No, we're just talking aces, so there's 4. So are these 2 sets disjoint, or are they? So if there's 6 face cards, 4 aces, that means the total face cards or aces is 10. Now we're going to say red cards. So how many red cards are there? 26. And how many 10s are there? In the whole deck, there's 4. Now, are there some overlapping cards here? How many are overlapping? 2. So our formula says that we add up the number in each set and then subtract the ones of the overlap. So 26 plus 4 minus 2 means that there's 28 in the set R or T.